Hello everyone, and let's take a look at question 4 of the exact same activity or same exercise 6.1. Just moving on to question 4. Question 4 is a very important question to improve our understanding of the Doppler effect. Alright, so it reads that in places like Canada, during winter temperatures can get as low as negative 35 degrees Celsius. This affects the speed of sound in air, and you can use the Doppler effect to determine what the speed of sound is. On a winter's day in Canada with a temperature of minus 35 degrees Celsius, a source emits sound at a frequency of 1050 Hz and moves away from an observer at 25 meters per second. The frequency that the observer measures is 971,41 Hz. What is the speed of sound? Okay, well, how we can determine this is we're looking for V, alright, just V alone. So what they gave us here in the question that they were so kind to, okay, this is question number 4. They gave us that the speed of the sound source was 25 meters per second, and it's moving away, so that's a positive 25. And then the sound source Fs was 1050 Hertz, okay, while the listener heard it at 971,41 Hertz. Okay, and we're looking for just the speed of sound in air on a normal winter's day in Canada. Alright, perfect. So let's just rule our margin. Alright, so the Doppler effect formula, as we know, it's given by FL is equal to V plus minus VL all over V plus minus VS, alright, times Fs. Alright, so this is how the formula is going to look based on the scenario that they've given us. FL is equal to V plus VL all over V plus VS, alright, times F of S. Okay, now we know that that was 0, VL was 0, so we can write that in there. V, because it's 0, all over V plus Vs F of S. Now this is where the rearranging comes in, okay, because now we need to restructure our whole formula, okay, and this is where a lot of writing is going to come into play. Alright, now I simply just can't do a lot of fraction inversions here without showing you the mathematical reasons why, but I'm not going to do that. I'm going to show you the mathematical reasons why. Okay, so first things first, I'm going to get all my frequencies on one side and keep all my V's on one side. Okay, so I'm going to divide this side by Fs, okay, as well as this side here. Alright, therefore I have FL over F of S is equal to V over V plus Vs. Right, so what I have here now is what I'm going to do here is I'm going to group this, alright, and multiply it by itself so I can get rid of this fraction, okay, and then what I'm going to do the same to this side as well, so I'm just going to use 2 asterisks here for this, okay. Then I'm also going to divide, I'm going to times, alright, I get rid of the Fs here on this side as well. Now I'm going to have Fs of this, so to bring it a little clearer, I'm going to have V plus Vs times F of L is going to equal V times F of E times F of S. Now what I want to do is I want to put all my V's and all my F's again on this side, so I'm going to divide this side by F of L as well as this side by F of L. Alright, those will cancel. Then I'm going to divide this side by V as well as this side by V as well. Therefore I'm going to have V plus Vs all over V is going to equal f of s over fl. Right. Now that was the hectic piece of math there that we had to do. So the reason why I wanted v plus vs over v is because here I have v over v and I have vs over v. So v over v plus vs over v, all right, over here. So that means I can say I'm going to continue up here. Maybe I should just erase this part here of this line. All right, just a little bit. All right, and then I'll just draw it over here. There, then I can have some more space to work with. All right, perfect. All right, now over here I'm going to continue, but I'll rule a line down here as well, just to separate the spaces. All right, so I had that, so now I have 1 plus vs over v, because v over v is 1, is equal to f of s over f of l. All right. Keep in mind, going back to the question over here, that we want to know what is the speed of sound. All right. Now that I have that, all right, I want to have, or I can take this 1 over to the other side. So I'll have vs over v is equal to f of s over fl minus 1. All right, now on this side, my 1 now transposes into frequencies and not velocities. So I have f of s over f of l minus 1. This 1 can be seen as f of l over f of l. So therefore, my equation now reads v s over v equals f of s over f of l minus f of l over f of l, because of that 1 there. All right, f of l is 1. Therefore, it becomes vs over v equals f of s minus f of l. All right, minus f of l minus f of l. All right, but all right, we must not forget this f of l as well. Remember, it's f of l over f of l, so minus f of l. All right, so that means we can group it into 1, and that will become vs is equal to vs over v is equal to f of s minus f of l all over f of l. All right, so that this one can come out over here. All right, let me just rule a line over here, or erase this line over here. All right, there we go. Okay, now that we have that, all right, we now need to get v back to the subject of the formula, and this was the cross multiplying comes in again. So what we're going to have to do is we're going to have to multiply this side by v to cancel, as well as this side by v as well. All right, then we're going to have to multiply this side by f of l to cancel, as well as this side by f of l. And what do we get? We get f of l times vs is equal to v times f of s minus f of l. All right, now we divide this side by f of s minus f of l to get rid of the fraction, and we do it to this side as well. And therefore, we get our equation to be v equals vs times fl over f of s minus f of l, which equals to, we can sub in here, f of l was 971,41 hertz all over 1050. All right, minus, is minus? Yes, minus, of course it's minus, I can see from the formula, minus 971,41 Let's just rule a little extra line there. Now we got to multiply that by 25. All right. Therefore, at the bottom of your screens, v equals to, the speed of sound in light is equal to 309 meters per second. Sorry, the speed of sound in air on a winter's day in Canada at negative 100 and negative 35 degrees Celsius. Sorry, okay, this is the speed of sound at negative 35 degrees Celsius in Canada in winter. Alright, quite a hectic question. Alright, but I would encourage you to watch this video again if you still don't understand, and watch and listen carefully to my explanations, and maybe write down what I'm writing down on the board on a piece of paper and really follow with me so you can understand how to do this question a bit better.